Hello everyone, my name is Harvindra Anaki Murli. My metric number is CE220042. So we are from Group 5 and for the numerical method final project we did interpolation Newton divided difference. So these are my group mates. So Yadavan Analaki Kalichelvan and Devanath Ananarki S. Ravindran. So, for the introduction, COVID 19 is caused by a new coronavirus SARS-CoV-2. It started in Wuhan, China in December 2018. The pandemic disturbed daily life, especially with movement control orders (MCO) to reduce the spread. Meisha reported its first case on January 25, 2020, and cases increased rapidly in March 2020. The government responded with early detection, diagnosis, isolation, and quarantine measures and enforced an MCO to control the outbreak. The MCO restricted many activities except for essential services, reducing traffic and industrial pollution as people stayed home and business closed. Major air pollution mainly comes from vehicles, industries, and open burning. Air quality is measured using the Air Quality Index API, following on fine particulate matter PM2.5. Based on the National Air Action Plan, API Measure API system is similar to the US Environment Protection Agency US EPA system. The API value based on the highest level of 5 key pollutant indicates the main pollutant and high health risk. Figure 1 shows the API value is determined. So this is a figure 1 flowchart for calculating API value, and table 1 below shows the comparison of API. And next is a project background. So our project investigated the air quality status in nations, urban and suburban areas during a COVID-19 pandemic. Based on data obtained from the online article, this article provides insights into how air quality changed during the pandemic, which saw a reduction in activities such as traffic and industry operation due to the movement control order. The article provides detailed data on air quality, especially focusing on changes observed during the pandemic. To approximate the cumulative API values for the month 4, we will use two mathematical interpolation methods, which is Lagrange interpolation and Newton divided difference. These will help us estimate the API value data points for April month, which is for based on the available data from other month. So next is interpolation methods, which is Lagrange interpolation and Newton divided difference. These will help us estimate the API value data points for April month, which is for based on the available data from other month. So next is methodology. The suitable method to solve the problem. These studies aim to approximate the air quality status during the COVID-19 pandemic in an urban and suburban area of Asia. The data source for this research is study for the air pollutant index API status in various cities in Asia before, during and after the implementation of the MCO in 2020. Quantitative methodology. To achieve this, we need use quantitative method based on Lagrange interpolation and Newton's divided difference to approximate the air quality status during the pandemic. Both Lagrange and interpolation Newton's divided difference method provide a reliable means of approximating the air quality status based on the discrete data points. Wellness serves as an effective tool for validating manual calculation, ensuring the precision of in the interpolation process. Using these methods, we can effectively approximate the air quality status during the COVID-19 pandemic in Malaysia, providing a valuable insight into the how MCA affected air pollution levels in urban and suburban areas. So there are two different numerical methods used to solve the problem: Lagrange interpolation and Newton divided difference. So first, the Lagrange interpolation consists of four orders: Lagrange interpolation and Newton divided difference. So first, the Lagrange interpolation consists of four orders, which is linear approximate passed to the 2 points given points, and quadratic approximation passes through three given points, and cubic approximation passes through four given points, and last is quadric approximation passes through five given points. After after that, Newton divided difference. So step one, construct a table using a given data, and we need to find each and every values using these two value. So these are the formula. So next is how to analyze and discuss the method. To approximate the cumulative API value, we use Lagrange interpolation and Newton divided differences. So for the Lagrange interpolation, uh, for the manual calculation, Lagrange interpolation constructs an interpolating polynomial as a weighted sum of Lagrange basis polynomials. Each Lagrange basis polynomial is calculated using a given data points, ensuring that the polynomial passes through the each data point exactly, and we can verify it with MATLAB. And second is Newton divided difference. Newton method constructs the interpolating polynomial incrementally by using divided differences. The divided difference table built using a given data point to find the coefficient of a polynomial. It also can verify using a MATLAB.
Okay, I'm Yadavan Analaki Kalachelvan. My metric number is DE210037. So I'm gonna explain about results and discussion for Lagrange interpolation using manual calculation and MATLAB calculation. So with the graph given, by the time no MCO, conditional MCO, and recovery MCO. So between this study, we have taken the values between February to July in the month. Then using the Lagrange interpolation between February to July, we have gotten the API values 51, 56, 53, then so on. So we have to calculate the in-between value. April is April. So for linear approximation, we will be using 2 points with the formula given. We have been calculate and gotten 54.5, and for quadratic approximation with 3 points with the formula given, we have gotten ourselves 56.6667, and the error is 8.67, and so on for cubic approximation with 4 points. With the formula, we have gotten 54.833, and the error is 6.833. And lastly, for quadratic approximation with 5 points, with the formula given, we have gotten 53.4, and the error was 5.4. Okay, so as for the MATLAB program calculation, we have to input the data points for February, March, May, June, and July, because we want to find out the April calculations. So the API values. So X is April, point to interpolate. So for linear explanations, we will be using 2 points. So we have to input the Lagrange interpolations, the formula, and so on for quadratic approximation 3 points, cubic approximation 4 points, and quadratic approximation 5 points. We have to include all the formulas for the each interpolations. So the function of P is Lagrange interpolations x, y, and the April. So we have to input the n for length, and P is equal to 0. So with all these programs, we can straight away run, and then we have gotten ourselves linear explanation x equals to the x April. We have gotten ourselves 54.5, 56.67, 54.83, and 53.40. So in the earlier, In the manual calculations, we have gotten quite same the value. For linear, we have gotten 54.5, exactly the same one. For quadratic explanation, we have actually gotten 56.667. Here is the same thing. And for cubic explanation, we actually gotten 54.833 as well as in the MATLAB. And finally, for quadratic explanation, here we gotten 53.54, the same as in the manual calculation. Thank you.
Hi, my name is Devana Anlaki Aswendel, and my matrix number is CE220129. And today I'm going to present my. Uh, I'm from Group 5, and today I would like to present Newton's dividend difference using manual calculation and matlab calculation. Matlab simulation. So this is the Newton's dividend difference. So this is the table. So the first Newton dividend method is uh, so this is the formula for finding F01, F11, F21, F31. So you get your final answer. And second Newton dividend law, you just have to find 3. So 3 only. So you get your final answer is just the same. But this time is x2 minus x0. And this is x3 minus x1 and x4 minus x2. And next is the third Newton dividend difference. So this time is x3 minus x0 and x4 minus x1. That's the difference. And next is the fourth, finally is the fourth Newton dividend difference, which is f13 minus f03 minus over x4 minus f0, x0. So you get your final answer. And our interpolation where we get is 53.4. And next, I'm going to share my MATLAB simulation. So this is my MATLAB simulation. So this is the coding, and I'll run it. So this is it is same as the manual calculation. As you can see the answer. So as well as the interpreted value is 53.4. So that's all from me. Thank you.
For the conclusion, both methods are effective for polynomial interpolation but differ in their computational strategies. Verify the manual calculation with MATLAB ensure the reliability of our result. The method yielding consistent and accurate results, as confirmed by MATLAB, is considered suitable for solving this problem. By utilizing both manual calculation and MATLAB verification, we ensure the robustness and accuracy of our approximation for the cumulative API higher quality for the April month. Thank you.